right, let's quickly talk about separable equation. So separable differential equations are ones that you can write in this form. Some function of y times dy equaling some function of x times dx. So you're effectively separating the two variables. Now, they're pretty easy to solve, as you'll see in a second, but the downside is sometimes you can't get what's called an explicit solution. So what all that means is you're not going to get y equals something. Sometimes you're going to get some function of y, like y to the third plus sine of y, is equals to some function of x. It's still a solution, but it's not an explicit solution. And sometimes your teachers will ask for an explicit solution. So once you'll end up with an implicit solution, you have to go through some algebra and try to make it explicit. So let's go ahead and look at an example. Here we have minus x squared plus 1 minus y squared all times y prime equaling 0. So this doesn't look separable at first, but we got to do some algebra to make it look separable. So what I'm going to do is move the x squared to the other side. I'm going to have 1 minus y squared times y prime equals x squared. And now, it always helps when dealing with separable equations to write your derivatives in terms of differentials. Okay? If you're iffy on differentials, make sure to go back and watch the video on differentials in Calc 2. So I can write this as dy dx equals x squared times this thing. And now I can take the dx to the other side and have 1 minus y squared times dy equals x squared times dx. All right, so now all I got to do is just integrate both sides. And on this side, I will get a y minus y to the third over 3 plus c equals x to the third over 3 plus, we can say plus another c, but one c is enough. It's just a constant. We can add them together and make it one constant if we want to. So now this is a perfectly good solution. I would suggest go ahead and actually simplify it a bit so that it's not really ugly. Multiply everything by 3. I'm going to get a 3y minus y to the third plus c is equal to just x to the third. And I don't need to multiply my constant by 3 just because it's a constant. It doesn't matter. I can scale it however I want to. So, and that is a perfectly fine answer. It's an implicit solution, right? If I write it in this form, 3y minus y to the third is x to the third plus c. You can see that the left-hand side is a function of y and the right-hand side is a function of x. So this is an example of an implicit solution that you cannot make explicit. Just because you have a y and a y to the third, there's no way to sort of factor it out or play some algebraic trick on it. But in some cases, you will be able to make your implicit solution explicit, and in those cases, you should probably go ahead and do it if your teacher asks you. So there you have it.